Hi everyone, my name is Blake Atkinson, and the title of my module for today is Would Farming in the South Pole Save Its Ozone? Comparing nitrous oxide trends in different regions of the globe. First, an important question. What exactly is nitrous oxide? Well, nitrous oxide is a potent greenhouse gas. Its structure is shown on the left. And for those of you unfamiliar with what a greenhouse gas is, a greenhouse gas, which is highlighted in the diagram by the red box, is a gas that traps radiation sent from the Earth and sends that radiation back down towards the Earth. In addition to being a greenhouse gas, however, nitrous oxide forms nitric oxide, which can help mitigate ozone depletion through reactions with chlorine radicals. Here I have exhibited the nitrous oxide to nitric oxide process within the overall scheme of atmospheric chemistry. The nitrous oxide is emitted directly above the tropopause, whereupon it reacts with an oxygen radical to form nitric oxide. This nitric oxide acts as a reservoir for chlorine radicals that react away ozone. Think of a reservoir as this giant sticky ball upon which chlorine radicals stick to and are subsequently not allowed to react with ozone. Nitrous oxide comes primarily from soil sources. This table exhibits two types of sources for nitrous oxide: anthropogenic or man-made sources and natural sources. As you can see, agriculture is the biggest contributor to anthropogenic sources of nitrous oxide, whereas soils under natural vegetation is the biggest contributor to the natural sources of nitrous oxide. What we've learned about nitrous oxide brings up an interesting question. As we're probably familiar with, the poles of the Earth are experiencing rapid ozone loss. Thus, if nitrous oxide is a precursor to nitric oxide, which acts as a reservoir species for chlorine radicals, would farming in the Arctic help save Arctic ozone? To help answer this question, I wanted to see if we could explain the depletion in Arctic ozone due to simply a lack of nitrous oxide in the area. I took nitrous oxide levels in the South Pole and compared it to three other locations: Barrow, Alaska, Mauna Loa, Hawaii, and American Samoa. Two of these locations, Mauna Loa and Samoa, are in very temperate climates, meaning we can expect to see a greater amount of soil and release of nitrous oxide from the soil. Barrow and the South Pole, in contrast, are very cold climates. The South Pole is the South Pole, and Barrow is the northernmost town in the United States, located in Alaska. I took the monthly averages of nitrous oxide since the year 2000 and plotted them on a graph. The results are shown here. As you can see, the levels of nitrous oxide don't vary that much from each other by geographic location. In fact, after taking a trend line of each dataset, these datasets are the Mauna Loa dataset and the South Pole dataset, I found that the rate of increase of nitrous oxide per month didn't vary between each dataset all that much. More specifically, the Mauna Loa dataset had a slope of 0.07 and the South Pole dataset had a slope of 0.071. Thus, there's only a 1.4% difference in the rate at which nitrous oxide increases in each location per month. So why doesn't nitrous oxide vary much by geographic location? Isn't the Arctic made of ice? Well, if we take a step back and look at it, nitrous oxide has a large lifetime, which allows it to subsist for long periods of time around the globe. This large lifetime, in effect, allows nitrous oxide to mix evenly throughout all parts of the Earth. Thus, would farming in the South Pole really save Arctic ozone? Well, probably not. For one, you could do that farming just about anywhere. It doesn't have to be in the Arctic, since nitrous oxide has a large lifetime. And it's safe to say that if the Arctic is experiencing a really bad ozone problem, despite having comparable levels of nitrous oxide with other regions of the globe, it's probably not the source of its issues. If you're interested in learning more about the data that I used to make the plots shown earlier, here are their sources.